Okay, for this next recording, I'm going to try to go over some of the output with you. We're not going to learn how to put this information into SPSS, but the idea that you can interpret an output screen will be very important. First, a little bit of a review. Think back to what we just did last week with a one-factor ANOVA. We got an F ratio. Do you remember that? And the F ratio was the variance between groups over the variance within groups. What do we want to happen? We want the variance between groups to be large because that reflects the treatment. So hopefully the means between groups are quite large. Variance within groups reflects the spread of the scores within any group. We want that number to be small because that really reflects error. We take that one step further with the two-factor ANOVA. We don't just have variance between groups over variance within, but now the variance between group is divided or partitioned into three types of effects. So now instead of just having variance between groups, in the two-factor ANOVA we have three effects we can look for. So the variance between group is partitioned into the three statistical effects. The first one being the variance due to the main effect of alcohol, the second one being the variance due to the main effect of pills, and the third one is the variance due to the interaction of alcohol and pills. And in each one of these situations, we divide it just like we did in the one factor over the variance within group. And we want that number to be low. So to be statistically significant, we want the numerator to be high for the variance main effect of alcohol and pills and the interaction. And we want the denominator, the variance within group, to be small. So I hope that makes a little sense for you. Let's take it a step further and actually look at the table below. And you'll want to take some good notes on the table so that hopefully this works for you. So notice here we have a table. It doesn't have variance between group over variance error. Instead it has source. It has alcohol, pills, alcohol by pills, and error. And so those are the three statistical effects. Alcohol, main effect, pills, main effect, alcohol by pills is the interaction, and the error is the denominator. So let's take a little closer look at where these numbers come from. First of all, the sums of squares for alcohol. Do you want that number to be high or low? The correct answer is you want that number to be high. And what's going to make that number high? That number, the 4,800, comes from going down the matrix and looking at the marginal means for no alcohol versus alcohol. So it's basically that number is being computed from the 90 versus the 50. We actually got the grand mean at 70 and did subtraction, squared, and multiplied by 3 or 6. You'd basically get 4,800. So if those numbers are large, that means that's a good thing. That means your variance due to the main effect of alcohol is large. Notice it then says 1 degree of freedom. Why do you have 1 degree of freedom? Because you have 2 levels of alcohol. So 1 degree of freedom there. And then it gives you the variance for alcohol. 4,800 over 1 is 4,800. And then it gives you the F score. The F of 355. Can you figure out where that F score came from? How does it go from 4,800 to 355? Well, it does that by putting the variance due to the main effect of alcohol over the variance within group, or error here. So let's go down to that error line. The error line is really the source of the sums of squares within group. So notice it got 108 there. Let me just go with you through this, and I hope I don't wreck everything for you here. How does it come up with 108? Well, if you look at it, go back to the original matrix in E, what is the sums of squares for 100, 100, and 100? Well, the sums of squares is 0 there. There's no deviations there. Okay, let's go to the one on the right. What is the sums of squares for 78, 80, and 82? Well, every odd number, the sums of squares there are 8. Then, what are the sums of squares for 75, 80, and 85? 75 minus 80 is 5, squared is 25. 85 minus 80 is 5 squared is 25. So if you have 75, 80, and 85, the sums of squares are 50. And it's the same thing, sums of squares for 50 for 15, 20, and 25. So in this case, if you add 50 and 50 again, and then 8, you get the sums of squares within group at 108. So in this particular situation, the sums of squares within group is 108. You have 8 degrees of freedom because you basically have 2 degrees of freedom within each group. You have 3 people in each group, so 2, 2, 2, and 2. So 108 over 8 is 13.5. That's the variance within group. We want that number to be low, and then to get the F score of 355, it's the variance due to the main effect of alcohol, 4,800, over the variance due to the within group variance, 13.5. The F is 355. Notice sig, it says 0, but that means basically sig less than 0.001. So you would write this out, and you would say F, and then in parentheses, 1, 8 equals 355. P is less than 001. And your real world statement would be, when people get alcohol, their performance is diminished. You wouldn't say anything about Xanax. We could then do the same thing with the pills, but this time we're not going down on the matrix, we're going across, but the means, the marginal means, were still 90 and 50. 90 and 50 leads to the sums of squares of 4,800. You have 2 levels of Xanax, so 1 degree of freedom, 4,800. You divide it by the same mean squared variance within group, 13.5, 355. So you'd say for the main effective pills, F of 1, 8 equals 355, P less than 001. The real world statement, when people take pills, performance is diminished. And then finally, and most importantly, is there a statistical interaction? The sums of squares there, it says 1200. There's no simple way to compute that, but the way that's actually done is the more non-parallel the lines, the larger that number will be. So the sums of squares for that is 1200. 1200 over 13.5 is 88. So the same idea, F for the interaction, 1 and 8 equals 89, P less than 001. And this would be the most important statement to make. If you combine pills and alcohol, motor performance is greatly diminished. It is a statistically significant interaction. So hopefully this all makes sense to you. If it doesn't, just listen to it again. And I think I'll stop this recording and just make one last recording for the homework. Thanks. Bye-bye.